this section is section 01, so please submit it accordingly to your section. Alright. Okay, so that's it for this one. And you will got it two email, right? That contain question 1 and also question 2. And please do not share that question among your friend. Okay. All right. So do you have any question regarding to test one? Anything that you want to ask? No? Okay.
Sir,
Yep. Yeah, Tajwa. Yep.
from chapter 4, which is dynamic characteristics, is there anything particular that's going to come from that chapter? Because like almost all of the questions are basically from chapter 5.
Yeah. For the chapter 4, right? The basic thing that you need to concentrate on, which is the first order, right? Okay.
Yes.
The first order system, yep, is what we call it, normal question that will be asked, right? So please look at the first order system, okay? So in this case, you need to be able to draw, okay? Uh, Sorry guys, so today I need to be a baby sister. Wait a minute, right? Okay. Why? Why are you crying? All right. Sorry for that. Okay. So if you look at here, right, you need to be able to draw your first order system. Okay. So in the first order system, you have a two parameter that you need to remember, which is t, right? And then what is mean by t? That's mean 63% of the final output. Okay. So that's mean this is the final output one, right? The final output is the output that your first order will be at the steady state error lah. Okay, this one we call it steady state error. So this one will be equal to 0.63. Okay, right? And then you will have 2t here, right? 3t here, right? Right? And also 5t, it can be equal to 5t. So the accurate value or the final value is at the 5t, right? This one. Okay. And for the equation for the first order, so this is the equation, right? Yt equal to y initial plus y final minus y initial 1 minus e minus t over time constant here. Okay. So remember your time constant is at here, right? In terms of second, it's not here. Okay. This is your time constant. This in t. This is the yt. Okay. Right. Did I answer your question, Tajwa?
Yes, thank you, doctor.
Okay. Let's look into that. Right. Okay. All right. So um, can we start our class? All right. For our the next chapter. Okay. Do you have any question about test one that you want to ask? No? Okay. All right. So let's proceed for our next chapter. Uh, we will go first on the Western Bridge first, right? Okay, because this one is a very simple chapter. Okay. All right. And then after that, if we have time, we go to the chapter 6, which is filter. All right. Lecture 7, bridge circuit, right? So what is used the bridge circuit? Okay. Uh, Before this, we have learned about amplifier. Okay. All right. The amplifier. So now let's say you have, uh, for example, this is your transducer. You have the degree and also your transducer converted into millivolt, right? And then you will have your amplifier to amplify it maybe in terms of voltage here. Okay, so this is the purpose using the OM, right? Okay, amplifier. Okay, and some of the sensor, some of the transducer, right? The output is not in term in millivolt, so it can be in term of ohm, right? Resistance. Then you want to convert it into voltage, right? So in this case, you can use the Western bridge here, okay, WB, right? So Western bridge is used to convert the impedance variation, right? Impedance variation, that means sometimes your transducer output is not in term of ohm, it can be in term of capacitance, right? Maybe a microfarad. So you can also can use the Western bridge to convert in terms of voltage. Okay. So why we need to convert in terms of voltage, right? Okay, let me show you. Okay, for example, this is the transducer for temperature sensor. Okay, temperature transducer. So now it detect 20 degree here, right? So maybe the value in term of ohm, it give you 120 ohm. Okay, 100.0 ohm. Okay, for example. And then your temperature increase 21 degree. Okay, it increase to 1 degree. So your resistance of this transducer maybe 1 to 0.1. Okay, right? So uh, the difference between 20 and 21 is about 0.1 ohm. So it is a very small, right? It is very small, right? So that's why you need to convert it into the voltage. So for example, 120 ohm, maybe when you to convert it into the voltage, you got it about 2 volt, right? So for the 21 is 120.1. So when you convert into voltage, maybe you will got it is 3 volt. Okay. So that is large difference is 1 volt. That means when you measure it, oh, okay, I got it is 1 volt. Yep, that means is 21. Right. Compare it when you got it 0.1, right? Okay. So it will be quite difficult when you measure it in terms of what we call it resistance, because the resistance is also affect you depending on your wire, right? Okay, your wire sensor and so on, so you also have the resistance. So that's why we try to convert it into the voltage. Okay, all right, that is the purpose using the Western bridge. Okay, so how to draw the Western bridge? It contain a few resistor, that's mean 4 resistor, okay, right here. Okay, and then is has been what we call it in orientation in a diamond orientation. Okay, never mind. So let's look this one. So Western bridge, there are 4 resistor here. I'm very like to draw like this one. Okay, okay. So there are 4 resistor, 1, 2, 3, 4. Let's follow that one. R1, R2, R3, and also R4. So what is it inside this one? This is the terminal A and also terminal B, the point A or point B. And then inside this one, we call it is offset voltage. So delta B, we call it offset voltage. where you put your multimeter at here at this point A and B. Okay, and then of course you have the supply voltage which is V in. Okay, all right. So how to derive this formula? So in order to find the delta V is equal to voltage at point A here, you minus the voltage at point B here, VB. So now you can got it is VA, that's mean actually the voltage at R3 here. So we can do the voltage divider concept. R3, R1 plus R3. So now you time with V in. Alright, so minus with voltage VB is a point at B here. So R4 you divide it is R2 plus R4. You time with V in. Okay. Right. So this is the formula for Western bridge. Okay. So that's mean um, let's look. Uh, it is depending on your V in. Okay, your V in here. Okay, and also the resistor R1, R2, R3, and R4. Okay, and then when you derive the equation, sometimes you will got it the voltage in terms of negative, right? So it doesn't matter because sometimes you can take it VB minus VA, right? It doesn't matter, right? So we just want to look in terms of the value. Okay. All right. So uh there is one words when we call it when the delta V is equal to 0. So this one we call it null or balance. All right. So that means when the delta V equal to 0, so when this is happen, that means this bridge, we have the right bridge and also we have the left bridge. It will give you the same value. That means VA equal to VB. Okay. Right. So when that one is happen, so you can see that is the formula delta V equal to 0, then you got it is R3 time with R2, okay, equal to R1 time with R4. Okay, so where do you get this formula is based on this one. Okay, delta V equal to 0 here, and then you multiply R3, right, R2, R3 here, plus R3, R4 here, minus R1, R4 here, right? Yep, minus with R3, R4 here. Okay, so you divide it with R1 plus R3, R2, and plus R4 here, right? So when this one multiply with this one, okay, I think I need to adjust. Okay, so when this one you multiply this one, then you got it is 0, R2, R3, plus with this one we cancel out. So R1, oh sorry, minus with R1, R4. Alright, then you got it the same formula with this one. Okay, alright, okay, alright. It's two formula here, delta V, right, this one. And when the delta V is null or balanced, you can get it another formula R3 times R2 equal to R1 times R4. Okay, so what is mean null and balance? That's mean at this point you got it is 0 here. Okay, and then how to make all this offset equal to 0? That's mean you can use the same resistor. For example, let's choose 500 ohm, and then this one is 500 ohm, and this one is 500 ohm, and this one is 500 ohm. Okay, so R2 times R3 equal to R1 times R4. 500 times 500 equal to 500 times 500. So here we got it is delta V equal to 0 here. Okay. Later on, I will show you how you apply your transducer in this Western bridge. So right now, I want you to get the concept of the Western bridge. Okay. So far, so good. Do you have any question? Ada apa-apa soalan? Is it clear? Yep. Clear or not? Do you have any question about this one? Yep. LCT, what is it? If you use KVL, also same. Kirchhoff voltage law. Yep. Also same. But this one you can use the voltage divider concept, right? Okay. Do you know the voltage divider concept, right? Yeah. Okay. Good. If you draw this circuit, you close this one, right? Okay. So in order to find the VA here, it's R3 divided with R1 plus R3, you time with V in. Okay. That is the concept. Okay. So let me proceed. Alright. Okay. This one done. Okay. Right. So now let's look how can we apply our transducer, right, in this Western bridge. Okay. So let's say our transducer is detect degree. Okay. It detect temperature. Okay. And then the output will be ohm. Okay. So right now you want to apply a transducer in this Western bridge. Okay. Let's say we want to measure the room temperature, right? The room temperature. Okay, by default, the room temperature will be 25 degree, and the initial value is 120 ohm. Okay, by default lah. That means when you put your transducer inside a room, so by default is 120 ohm. Initially is 120 ohm at 25 degree. Okay. So right now you apply your transducer. Let's say I apply it is at here. Okay. So the symbol will be a variable resistor, right? Because your transducer resistor will be changed, right? Depending on the temperature. So this is your what we call it transducer. So resistor transducer, for example, RT here. So by RT, now you got it is 120 ohm by initially. Okay. All right. And then in order to start the what we call it the measurement, right? So when you put in your multimeter, right? So your multimeter by default need to read 0, right? For the initial value, need to read the 0. Okay, the first one is 0. Then I can start to do some measurement, right? So how to make this multimeter or this voltage offset equal to 0? So you need to choose all the resistor value with the same value with your transducer, 120 ohm, 120 ohm, and also 120 ohm here. Okay. Can you get it? Boleh faham? This is how you apply transducer in this Western bridge. Can repeat. Okay. Right. Okay. Let's say this is your transducer. Right. So you want to measure your transducer at a room temperature. For example, by initially your room temperature is at 25 degree. So your output of your transducer is 120 ohm, right? Then you apply your transducer as one of the uh, resistant in your Western bridge, right? So you apply at this one R4. Okay, so this will be your uh, transducer resistance. Okay, so by default your transducer resistance is 120 ohm. Okay, so of course when you want to start your measurement, right? So your multimeter, right? When you put your multimeter at point A, okay, So it should be 0 lah, right? So that you can start your experiment in order to measure what happened in the room temperature after that. Okay, so in order to make the 0 of your multimeter, you need to choose the value of the resistance 120 ohm for R2, 120 ohm for R1 also, and R3 120 ohm, right? And this is your resistor transducer is 120 ohm. So when you choose all the same value, if not, is what happened. Okay, if you choose another, for example, you choose 200 ohm, so this one is not equal to 0. It will be equal to what you call it, 2 millivolt, for example. Can you get it? Boleh, right? So that's mean after this, if you measure, for example, 30 degree, right? And this one, you got it about 4 millivolt, right? So the actual value that you need to minus 4 millivolt minus your offset value, 2 millivolt. Do you get it? Okay. Right. Yeah. Good. All right. So for to make it easy, so just make sure this your multimeter equal to 0 volt, right? So in order to make sure this 0 volt, so you need to choose 120 ohm. Okay, all right. And then you will think that, oh, doctor, the temperature will always change, right? After that, so if I use the fixed value, right? So maybe your temperature resistance here change it to 130 ohm, right? And then the bridge is not balanced anymore, right? You don't get a 0 volt anymore. So how to do that? So you just need to have another variable resistor, right? It's like the potential meter, right? So you remember the last time during your lab one, right? On your second year, so there is what we call it potential meter that you can adjust the resistance value, right? Okay, so when you got it is 130 ohm, you can adjust this resistance, right, to be 130 ohm also, right? So when you adjust 130 ohm, same with this one, you will got it is 0 volt. Okay, can you understand the concept? Boleh faham? Be clear. Okay, right. That is how you apply lah. That is how you apply your transducer. Okay, so alright. So if the temperature increase, ampere will increase to, yep, ampere. We're not talking about the ampere actually lah. Please, we're talking about the voltage. Yep, voltage. Yep, voltage will also increase. But it is depending on your transducer. In this case, your transducer output in terms of resistance ohm, right? So now you will look after you have the Western bridge, so you will look into what we call it voltage. Okay, good. So this is your Western bridge. So the output you will be millivolt, right? Okay. So we can say that the input is the changes of the resistance of your transducer, and then the output is will be delta V. Okay. So for the transfer function for Western bridge is equal to delta V over with delta R. Okay. So delta R is what? Is the changes, right? For example, the initial value is 120 ohm, then it change is 30, so the delta R is equal to 30 ohm. Okay, so the changes of your resistance, right? So your Western bridge is depending on the changes of the resistance. Okay, and then the output will be delta V. Okay, example 7.1 is a very simple question. Is a Western Bridge null? Wow. Is Western Bridge null with R1 equal to 1000, R2 equal to 840 ohm, and R3 equal to 500? Find the value R4. Okay, when the null voltage, that means you got it this equation lah, kan? R3 time R2, R1 time with R2, R4. Okay, and then you will got it the answer. Alright. So if we look at this one, need to draw again. Alright, so draw is again. Okay, so this one is delta V. So now you got it is R1 here equal to 1000, R2 equal to 842 ohm, and then your R3 equal to 500. Okay, and then it asks you to find what is the value of R4 when this one equal to 0. Okay, so of course it needs to be crossing, right? So R1 cross here, R1 times R4 equal to R2 times R3, right? So this one when the delta V equal to null, equal to 0. Okay, so number 2, if the resistor average is R1 120 ohm, R2 120 ohm, and R3 120 ohm, and R4 is 1 to 1. So everybody, this one 100, 1 to 0, 1 to 0, 1 to 0, but this one is 1 to 1. Okay, so you will got it. Find the voltage offset, so delta V. Alright, so this one you need to use the formula at point A and point B here. And then you got it minus 1. Minus is okay. Minus that means this value is more than this bridge, right? The bridge at the right is more than value bridge at the left. That means VB is more than VA is more than VB, right? If the formula you take it is VA minus VB, okay? So that's why you got it is negative. Oh, sorry, the bridge for VB is more than VA, right? That's why you got it negative. But it doesn't matter. This is only the sign. The most important thing is the value. Okay. If you take it VB minus VA, you will got it the same value with this one. Okay. You will got it the same value. All right. So far, okay. Do you have any question? All right. No? No, doctor. Okay, good. So the more important thing is this slide. Okay. The slide. Okay. All right. Okay. So let's say you use the same value of the resistance for all one. Okay. So this one you use the resistance. I put it R, and this one I put it R. This one I put it R, and this one I put it R. Okay. R that means the resistance value lah, right? So for example, 120 ohm, 120 ohm, 120 ohm, 120 ohm. Now we got it delta V equal to 0, right? So this one is the V. Okay. Now, how about there is a resistance change in one of your resistor. Okay. So how about this one, right? The resistance for this resistor is changed, right? Is varies over the time. So you will have another resistor. We call it delta R, right? The changes. Okay. For example, initial value 120 ohm, and then after that it become 120 ohm. So that means the delta R equal to 30 ohm. Okay. So how to derive this formula, right? Based on this condition. So you will use the same concept for this one. Delta V is equal to VA minus VB here. The same concept. So now you will got it the voltage at this one. So R divided with R plus R here. Okay. You time with the V in. Right. V in here. Minus with R plus with delta R here. Okay. Divided with R plus with delta R plus R here. Then you time with V in. So this one is delta V. Okay. Uh, it's different with this slide because this slide I put it delta R is here. Okay. To make it easiest, right? So just let's follow the slide. Okay, to make it easiest. So this one is R. This one is R. Okay. So now you got it is delta R here. So R plus delta R divided with R plus delta R plus with R. Now you time with V in. Minus with R divided with R plus R you time with V in. So now you can make it delta V over V in here. Alright. So this one will become R plus delta R over with 2R plus delta R. So minus with R over 2R here. And then you can simplify it, right, to be delta R over R and 4 plus 2 delta R over R here. So this is the formula, right? If you use all the same resistor, however, only one resistor that is changed based on the. So this is like your transducer, okay? So this the formula that you got it, right? And you also can simplify it again, delta R over R divided by 4. Okay, all right? So why I just choose 4? Because 2 times with delta R over R, okay, it will be this very small value, right? Okay, because your delta R, right? So the changes of your delta R are actually 0.004 or 0.001. It's a very small. So 0.001 you time with 2, then you will got it is 0.002. And then you divide it with ohm, for example, 120 ohm, right? So this one will be like almost 0. Okay, so you can ignore it, right? So you can use the simplest one, delta R over 4. Okay, so in this case, we can uh, look at this one. We can say that the input is delta R and the output will be delta V. Okay, all right. So this is the Waterm bridge. Okay. All right. So far, okay. Do you have any question? Boleh? Doctor, yep. Final equation. Yes, correct. What is it? How to get that? This one, delta R over 4, is it? Yeah. Okay. Actually, this one, right? So you can, this one is almost 0. Why? Because normally the delta R, right? The changes of resistance, right, is a very small. It's like 0.001 ohm. It's a very small. Okay. So that means 2 you time with 0.001. divided, for example, your R, for example, is 120. Okay, so this one will give you very small value, right? Zero, almost zero lah. Okay, so 4 plus 0.0001, for example. Okay, so you can say that, yep, I just take it 4. Okay. Okay, good. All right. So, any question? No. Okay, good. Let's proceed for example. Sorry, my daughter. Hey, she just watched the YouTube. Hey. Okay. Thinking for the Western bridge shown below shows that V out equal to 10 RT divided with 5 plus RT minus 5 volt. Okay. Yeah, this one is a simple thing. Okay. So try to draw your Western bridge to be like this one, right? So this one is V out. This one is 500. This one is 500 also. This one is RT. This one is 500. This one is 10 volt. All right. So we want you to find the V out. Yep, simple. V out, you just take this one point A and point B here. So here we got it is VA minus VB here. So RT divided with 500 plus RT you time with 10. Okay. Then you minus with 500 divided with 500 plus 500. Oh, this one you time with 10. Okay, that's why you got it is 10 RT divided with 500 plus RT minus with when you cancel out, right? So you got it is 5. Okay, yeah, that's it. This one is V out. Okay, shows that the sensitivity of V out with respect to RT is equal to 5 millivolt per ohm if RT equal to 500. Okay, all right. So this one, yep. Okay, sensitivity, right? So sensitivity, or sometimes we call it is transfer function. For this one is 5 millivolt over ohm. So for the transfer function, we know for Western bridge is delta V over delta R. Okay, it's 5 millivolt over ohm. So we have learned the formula for delta R here and so on. So that means now you use the delta R equal to 500 here. Okay, so you can see that all it use the same value, 500, 500, 500, 500. So that means it is like R, 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 and R here. Okay, so the sensitivity, all right, equal to that one. That's mean delta V over B in equal to delta R over with what we call it 4. Okay, all right. So now delta V over V in is 10. Delta R over 500 equal to 4. Now you can got it is what is it? Delta V to R, V equal to R. So 4 delta V equal to 10 delta R over 500. Okay. Now you can time some 10,500 times by 4. Okay, so you got it 40 divided with 500. So delta V over delta R equal to, I got it. So 40 divided with 500. 40 divided with 500. Oh, no. Why is not equal to 5 millivolt? I'm also forgot about it. Delta V over delta R. So 4. Oh, I'm wrong about it. So 4, 10. Yep. This one 10. This one you time with 4. So 10 divided with 2000, right? Okay. So 1 divided with 200. That's why you got it is 5 millivolt here. Okay. So the sensitivity of this Western bridge is equal to 5 millivolt. Okay. All right. Good. Okay. So for the V out here, right, equal to 0, right? V out is like the delta V equal to 0. That means if the delta R is equal to 0, that means there is no changes on delta R. Okay. So right now we want to look about the sensitivity of your Western bridge. So when you apply your Western bridge like here, 500, 500, 500, 500, and also the V in is 10, now you will got it the sensitivity of your Western bridge, right? This is delta R, this is delta V, equal to 5 millivolt. Okay, 5 millivolt, right? The unit is ohm divided with millivolt divided with ohm. Okay. Okay. So by having this sensitivity, that means whatever you got it, the changes of delta R, right? For example, maybe 1 ohm. So you can know 1 ohm, you time with 5. Now 5 millivolt. Now you can got it 5 millivolt here. And after that, if you got it is 2 ohm here, right? So 2 times 5, you can got it to 10 millivolt, right? Okay. So by knowing the sensitivity of the Western bridge. Okay. Clear? Is it clear? If you don't know this sensitivity, that means you need to calculate it again lah. Okay, like this one. All right. Okay. So I think and then if you play around with the Western bridge, you play around with the some we call it AC voltage, so it will be different. But this one it mean will not be covered for what we call it in this class. Okay. All right. So I think that's it for our class. So in order to cover for next topic, for the filter, I think it will take some time for it, right? So for the filter, because the slide is too long, right? I will cover it by next week. Okay. All right. And then I think our class will be stopped at here so that you can concentrate on your test one. If you have any question, you can WhatsApp me directly. All right. And yep, LCT, what is it? Tonight around what time we got an email? Uh, 8 to 8:20, right? Okay, 8 to 8:20. You will got it to email, right? You will got it to email. Doctor, just one more question. Okay, what is it? Do we have to derive the formula for gain during the test? Formula for gain. Uh, So what do you mean? For example, what is it? Muhammad Akib, for example, formula for game for, it's not clearly what you mean. The long derivation to get the, like let's say the gain is inverted amplifier. Yeah. Oh, I know. Do you mean like this one, right? Yeah, do you mean like this one, right? Correct. Muhammad Akid, correct, right? This mean this one, right? Okay. Alright. That means it is good to know lah. It is good to know. Alright. It is good to know how to derive this one. How to use the Kirchhoff law. It is good to know. But because you are in what we call it mechanical, so you just look at the circuit configuration, right? So when you look at, oh, this one plus going to negative, and you got it feedback resistor here R2, and also this is the R1 here. So and then the input here, so you know that, oh, this one is the inverting circuit. Okay, so the gain is minus R2 over R1, and how to get the V out, minus R2 over R1 times V in. Okay. The input impedance for inverting amplifier is this one lah. So like you can see that in the slide, right? So for example, the input impedance for inverting 1.5 kilo ohm. So 1.5 kilo ohm is here, okay, right? And then you can got it, the gain and so on, right? So to answer that, for how to derive this one, right, is for your own knowledge lah, alright? Is for your own knowledge, alright? Okay. Did I answer your question, Muhammad Akid? Okay, good. Welcome. Okay, bear in your mind, please look back the performance characteristic for measurement and instrumentation system. What the important about the operational characteristic, alright? Okay, what is the important static characteristic, okay, and so on. Alright, look at how you derive the accuracy, okay? How you derive the accuracy. Try to understand more about the accuracy, okay? So if you give some example about some instruments, so how to find the accuracy about it, okay? And what is the importance of the accuracy and so on. Right? Most of the question is about logical thinking, okay? Right? All right. Repeatability, calibration, and so on, okay? And the question until what we call it comparator, okay? Comparator until signal condition B. All right. Anything else? Yep. FCT. For assignment Q2, okay, comparator. Okay. Yep, the final table alarm, all right. Okay. Do we take the condition from table before, or we just make some new? Yep, you should take from the output from the table before, okay? Because this one will give you some truth table, right? One truth table, right? For example, okay, okay. So for example, this one, uh, it will give you output one, right? And then output two, and then you can say that output three here, okay? So all of these we give you the logical one. For example, you take 0, 0 and 1, 0, 0, 1, 1, 1. Then you will got it. This one is n, right? 0, 0, 0, 1. And then you got it another output. Let's say output 4 and output 5. And then you got it in output 6. Okay. Then the same condition happen 0, 0, 1, 0, 0, 1, 1, 1. So this also use the n 0, 1, 0, 0, 1. Okay. So for your alarm system, so you just need to combine output 3 and also output 6. So this is your alarm. Okay. 1, 2, 3. So now you just take it. Okay, this is what happened. 0, 0, 0, 1 and 0, 0, 0, 1. So you just multiply it, right? So your alarm is what? Will be triggered if one of the condition. That means or. So plus 0 plus 0, 0 plus 0, 0 plus 0, 1 plus 1, 1. Okay? Alright. What is out 3 equal to 1 and out 6 equal to 0? Okay. Because your out 3, right, it is depending on out 1 and out 2. Okay. Alright. Okay, Mr. Yo, I understand what your concern. Okay. If you just look at the final output, you just alarm, right? You just look at the condition for outputs 3 and 6. It will be have 0, 1, 0, 1, 0, 1, right? Okay, 0, 0, 1. Okay, if you just look at the alarm. So I can accept if you can have two different answer. Maybe you can put it at 0, 0, 1, 1. Okay, so this one 0, 0, 0, 1. Okay, so when you put like this one, it will describe everything if you just look at output 3 and output 6. So for example, 0, 0 and 0, 1. Okay, if you just give the what we call it, the table output 3 and output 6. Okay, if you can give overall table, yep, we can accept it. Do I answer your question? Boleh, Mr. Yo? Faham Okay, good. Okay, and please be careful with some words, right? Some words. This one is clear word, the line alarm system that will be triggered. Okay, if one of the condition. So sometimes it use the different words, right? Sometimes it use the word while and so on. Okay, okay. So please careful with that. Okay. And your test one will be 1 hours, right? And you have got 15 minutes to submit your answer script. And please do it quickly, right? For not if not jam nanti, right? Okay, to avoid the internet problem. Okay, all right. I think that's it. Do you have any question anymore? We got it 5 minutes more. Oh, dah left the meeting. Okay. Yep. Siti, what is it? Submission test. Okay. E-learning. Yes, correct. E-learning. So just go to yep. Make sure you have enrolled on this code, right? What about Faiz's name? Oh, do you got the guideline for the exam? Have you got the guideline for exam? Not yet. No. Oh, I'm so sorry about it. Okay, I will forward it to you. I thought that I gave it to you. Okay, I'm sorry. I'm so sorry. Okay. Um. Okay. Let me. I thought that I gave it to you. Yeah. Sorry. Sorry. Where is it? Think there's one guideline. Okay. All right. Okay. Thank you, SCT, for reminding me. Okay, this is the guideline. You will receive two part of question. That means you will receive two email, all right, and two question Q1 and Q2. And please do not share with your friends, right? Because everybody will got it different question. Okay. The link for attendance will be sent it to you. What we call it before the test. The time allocation for test 1 is 1 hour and 15 minutes. And you will receive a password for Q1 at 8:25 and Q2 at 8:40 p.m. Okay. And then your test 1 will end at 9:30 and then you got about 15 minutes. So you need to submit at this code, right? Right? And please submit accordingly to your section. Okay. For example, this one. So make sure you submit, okay, at section 1, okay. You are section 1, okay, submit section 1, okay. And you are allowed to submit only a single file, okay. You have the answer for Q1 and Q2. Please combine it, right? If you can, please combine it if you can. Actually, the e-learning can accept if you upload it multiple file. And then the submission link will be closed at 9:45, and do not copy from each other lah. So this is the file format. Okay, as it is, this is the file format. Put your name, put your metric number, and put your code. Right? If you SKMM or SMM, and this is your section, and this is your test 1. Okay, just put it test 1. If you have a single file lah. Okay, if you have both files, so I hope that you can combine it, all right, and then you can convert it into PDF. Okay, this is the timeline, right? 8 or question will be given. You have registered your email, right, into the link that I have given it to you. And then 8:35 you will receive a password. Then 8:30 you will start. 8:50 you will receive the password Q2, and then you will stop at 9:30. The duration test is about 1 hour. Okay, and then you got about 15 minutes to submit. All right, so I will forward this one through your WhatsApp group. All right. Okay, I thought I gave it to you. Okay, maybe I give to another section. Hi, sorry. This method I taught two section here, right? Okay. The section number 6. Don't ask for extra time, right? Because I'm late for give you the guideline, right? It's not, sir. Extra time, sir. Extra time to digest the guideline. Okay. All right. Any more question? Okay. So I think that's it. Already at 10. I wish you good luck. Any question you can WhatsApp me directly. Okay. I will see you again.